with them. I was a McDermott customer for about 25 years. Before I jumped the fence onto the supply side, I worked with McDermott for 6 or 7 years. And then they were kind enough to let me cut my pay in half and go straight commission. And it allowed me to sell other products, obviously non-competitive, but I can sell tanks and pumps and filters and things like that. So when a customer has an application and they say, hey, we want to add electropolishing, what kind of anodes do I need? I can say, I can get you those. I can build you bus bar. I can do those things. And one of the things that I got involved with was masking. And I sell masking supplies. I sell the lacquers and the plugs and the tapes and things like that. And I got into masking because when I was in sales working in a shop, so a customer calls up and says, hey, I need these right away. And you go out to the production manager, you say, hey, can you help? And, she would tell me, well, no, unless you want to run them yourself or unless you want to mask them yourself or something like that. So quite often I end up, in the masking department at 7 o'clock at night, putting plugs in holes because I made a commitment and can't say no. Once you make that commitment, that's it, right? So through all of that, I said, geez, everybody has a hard time reading blueprints, and all of the mistakes that I've made over the years really stem back to, hold on, I need to find, no, I can't, I need to find the screen sharing again, sorry. Gosh. So this presentation is all of the mistakes that I've ever made. Hang on, now if I'm back to the meeting, and all the tricks that have been played on me and all the things that happen. In metal finishing, it's very hard, and we don't have a lot of people in the shop that can read blueprints. So I took a blueprint class. I actually got certified by the state of Massachusetts to be a blueprint trainer. But I went to the school and I said, look, I don't want to be a machinist. I'm never going to make a part in my life. What I want to be able to do is put the plugs in the right holes, mask the right surface, find not rack the part in the wrong place. So by doing that, they helped me develop this presentation. And it is, like I said, it will never allow you to machine a part. You'll never be able to run a Bridgeport or something like that, right? But this will give you a pretty good background into, sorry, I thought I was more ready than this, into blueprint reading and in terms of what platers need to know. I did a class last week. I did this presentation, and these people had paid a lot of money to the state of New Hampshire to come in and do a blueprint presentation. And everybody walked out more confused than when they went in. So my goal is to just kind of tell you the things you need to know, tell you to be aware of some other things, and really be able to, get a part into your shop and do what you need to do to it. So this is me. Like I said, I represent McDermott Enthone, and there's a local distributor here, Roberts Chemical. Smaller customers go through Roberts, and they sell commodity chemicals and things like that. I have been in metal finishing for over 40 years. The second best masker I've ever known. There's certainly at least one that's better. And I have made enough mistakes that I have learned a lot along the way. So why is blueprint important for platers, for finishers? It really impacts every step of the business, right? When the parts come in, you do contract review, you do your incoming inspection. You need to be able to look at those prints. A lot of times the specifications are on the prints, right? So if you're trying to find out, how am I going to hard anodize these, the electroless nickel plating and such, you need to be able to find and understand that specification. If you're doing estimating and pricing, you're going to want to be able to read a blueprint. Otherwise, you're going to find out all of the things you don't know the hard way. Alloy identification, super important, right? Are we gonna take 2024 and give it a heavy etch? Probably don't want to do that, right? So it's important that we know where to find that on the blueprint. The biggest problem, the biggest cost incurred in many shops in terms of cost of quality is masking errors. The plug's in the wrong pole, the tape is on the wrong surface, right? 99 times out of 100, the absolute best place to rack a part, especially for anodizers, is the worst possible place for the people who machined it, right? There's that nice big hole in the center. And you say, oh, that's perfect. I can put that rack right in there and leave just a couple of small rack marks. And that's how I found out what flow honing meant, right? Because flow honing is a way to make a surface incredibly smooth. And boy, what damage the rack did to that, right? So dimensional tolerance is really important, right? We look at that, we say, we need 2 thou hard coat plus or minus a couple of tenths. Is there room? Did the machinist leave us room? And surface conditions. Is that a really smooth surface? Is that an important surface that I should or shouldn't be racking on? So where do you start? You start with the title block, and that's usually in the bottom right corner of the blueprint, right? And everything you need to get started is in there. And you can see the title block, and this is why I did it this way. You can see my my dock, but I wanted to be able to point. Usually there's the name, whether it's T has got his Raytheon company's name in there or something, a part name, the finish, heat treating, the alloy, that's really important, right? Drawing numbers and part numbers, not the same thing, right? The finish, surface, and I always go back sometimes when I'm looking at a print, I look at the date. It may just be kind of a thing for me, but if I'm looking at a blueprint and it's dated 1965, that may tell me that I'm dealing with something that maybe isn't quite up to speed in terms of what everybody was doing in 2021. And that happens, especially if you're doing military parts. We used to do cadmium plating, and we'd get parts that went to tanks that were being built in Vietnam. So just things to look at. This is also a title block, just a more complicated one. The other one was kind of a homegrown, very best machining company. This one is usually more associated with aircraft, military, DOD type of stuff. Same information, just maybe a little bit more and a little bit more formal looking, but essentially all the same things. But there are different kinds of title blocks, so you just want to be aware of that, So the title block has the critical info that we need, right? And we know we need the part name, we need the part number, we need to know what the alloy is, we need to know we nickel plating it, hard coating it, powder coating it. What are we doing? I also look at the revision number. You want to make sure, if you've done this part before and you're at revision 2 and you get the blueprint and you happen to look down and see that you're revision 5, it may be time to give the customer a call. Sometimes I look at used on, because if it says, bottle opener, then I may look at it one way. If it says landing gear or fuse or detonator, then I may look at it another way. It's, boy, we really need to be on our game with this one, And I look at things like next assembly too, because sometimes we get those, maybe it's a blemish, I don't even want to call it a defect, but there's a little bit of leakage from a hole or something like that. And, but if you're looking at something and it says cover and you look at it and it's obviously a cover and it's on the inside, it might be worth it. Instead of saying, look, we got to strip and replate these, it might be like, hey, let's call the customer. That little blemish I think it's on the inside of the cover where nobody's going to see it, And the list of materials, the bill of materials can, is sometimes in there. And again, I look for clues like landing gear, seat bracket, things like that, to say, okay, well, what's my real level of risk here? And the most important thing is the tolerance block. And that is this thing here with all of these X's, right? So what this is, when you look at a blueprint, if you see a dimension that goes out to 2 decimal place, two spaces after the decimal, okay, in this case, it's plus or minus 0.03, okay, that's 300 thousandths. So that tolerance is pretty wide open. If the dimension you're looking at goes out to 3 decimal points, that's plus or minus 10 thousandths. Again, very comfortable. I can hard coat that. I'm not worried about stuff. But if something goes out to 4 decimal points, right, that's plus or minus 5 tenths. So now if I'm powder coating something and there's a tolerance in there that's that close, I don't know if I can hold that tolerance. Did the machinist leave me room? If I'm doing hard coat 2 thou on a slot and I'm building up 1,000ths on two surfaces that are getting closer, and that tolerance is plus or minus 5/10, I really need to make sure I talk to that machine shop and make sure she left me enough room, because I've had it happen where, you do a wonderful job. You nail that hard coat exactly to thou. You send it to the customer and they call up screaming because the go gauge won't go. Well, because you didn't leave us enough room, and that can be true with fractions too, and angles, plus or minus 1 degree, things like that. So the tolerance block is very important. And these are areas. If I look at a print and I see 4 decimal points, I'm looking down to see what that plus or minus is, because that could be trouble. So here we are. We're back to the very best and very modest machining company from Maryland, and they are making this widget bracket. And if we look down at the tolerance block, we can see this is the one that was on the previous page, right? Got some plus or minus 300 thousandths, plus or minus 100. I'm sorry, yeah, the 10 thousandths plus or minus 5/10. So if we go over to the part, so we've got 3 decimal points here. Even though they're zeros, they're still placeholders. So that's saying 3 decimal points plus or minus 10 thousandths. Okay, I know I have enough room here. But if we look over here, now we're out 4 decimal points, right? So this dimension right here is plus or minus 5/10. So I got to be really careful. Now I need to make sure that I see that there's a close tolerance on there. So if I'm estimating, I need to make sure I price it accordingly. I might want to put a note about what I'm expecting my buildups to be, right? If I'm racking, 5/10 is not a big burr, and if you jam this on the wrong aluminum rack, you could raise a burr that knocks it out of tolerance, believe it or not, So you have to look at the tolerance block and then at the drawing and see where do my dimensions looking like. And in this case, there are two dimensions on this view that are out to 4 decimal points. So that's a problem. That's something you need to account for. So the tolerance block, good place to start, good place to check, and then look back at the part, right? So then when you're looking at the parts, you see these strange looking check mark things, right? And they have a number in them. And you say, what does that mean? Listen, if anybody has any questions, please just feel free to interrupt me. I do not have the chat window open, so I can't see that. So just feel free to, barge right in and join the party here. So, he said party, he's from Boston. So if you feel free to ask any questions though. So what this is a surface finish call out. This is what telling us how smooth or rough that surface has to be or can be. Okay. So you see all these check marks all over this part. And what do they mean? So what they really mean is it's the RMA, RMS value, okay? And what you as a plater really need to know is the lower the number, the smoother the surface, okay? And technically, this is a calculation between the peaks and valleys on a microscopic level when you look at the part, and the depth and direction. So if things get machined in a certain direction, milled or turned, or, you'll see that there can be lines, and we may not see them. And on a part that has a very low number, you can't even see them with a microscope. But that's what that little check mark is measuring. It's measuring the RMA value. Okay. So here is the long version, right? And you can Google this later and read it. It's a lot of information there. But again, like I said, the lower the number, the smoother the surface. So when you see something that's a 125, that's average. The machinist doesn't have to do anything special. All he's going to do is he's going to manufacture it the way he does. 125, very typical. When you see an RMS 63, getting down there, it's smooth. It's not a mirror, right? It's not polished smooth, but it's smooth, and it might be an area. If there's another place to rack it from, hard coders, then you try to find another place to rack it from. And if you see a number down low like 25, that means that is a very clean, smooth, polished surface. It might not be mirror finish, but it's very smooth. And do everything you can to stay away from that. Don't rack from it. Don't barrel plate them. Don't throw them in a bag, shove them in a box, and UPS them across the country. You want to make sure that area is protected. whatever you do. You don't want to change that. So it's a very low number. It's a very smooth part, kind of like sandpaper, right? So those little check mark things have some other meanings too. And that's why I showed you that picture. It has a lot of them. Some of them really don't mean anything to us as platers, right? But I want you to know what they are, so you don't have to, you don't get surprised by them, right? But you'll see, like this one here, when it's empty, it just means that surface may be produced by any method. Now, what does that mean? That means if it's something that I'm casting, the cast finish is fine. Right out of the extrusion machine, that finish is fine. We don't have to do anything to that finish to smooth it out. So whatever it is, it is. This one here with that's filled in, that says material removal is required. And in that case, we may have a dimension that's cast into something that they're like, yeah, we really, we need that to be tighter. So we need you to remove some material. So cast it big and take some away. And that way there, we know we're getting a surface finish, right? And in this one with the little circle in it, material removal prohibited. They don't want you to machine that. We extruded that in. Do not mess with it, right? Leave it alone, right? So those are other check marks. You say, well, they're all over the place, right? So if we go back to this part here, right? So what do we see? We got a 125 inside this hole, right? Pretty high number. Up down here, it says all surfaces 250, unless otherwise specified. So, there's some surfaces here they really don't care about. That they're not designating here, for instance. Actually, they are. Here they're saying this surface needs to be a 63 finish. This surface here has to be between 63 and 32. A 125, a pretty high number, not a big deal. This one here, they want you to machine this out. Okay, they want you to machine that out. You got to take that out. So that's one that we're going to look at, but we're going to say, hey, really doesn't affect us, right? There's nothing in this one. That means this one takes precedence. So these checks are just 250 because there's nothing there, right? But then down this end, we've got a 16 finish on this. It's hard to see. We don't have the full drawing, but we'll assume this is a round part. But there's a little pin that comes off the end of this. That's a 16 finish with a 2 thou maximum differentiation from side to side. So the important thing there is the 16. So if you're going to put these on a round rack or something and pinch it right from there, you're going to ruin that part. Okay. And if you make it so deep, because if you put a gouge in it that's more than 2 thou deep, it can't be fixed. Right. So when I look at this, I say, oh, it's a 250. And then I got a 32. I got to stay away from that. I got a 16. That's a red flag right there. So do not rack from that. So at contract review, might be a good idea to highlight that on the print and say, do not rack from this surface, right? Make a note because like I said, Murphy was a plater. He was a metal finisher. And if there's a place to rack it from, that's absolutely the worst place to rack it from, that's going to be the best place for you to rack it from, right? So just avoid those finishes. So there are other tolerance call outs, right? And there's different ways to call them out, but they add these dimensions to the print. You can use it for anything. You can use it for a diameter. You can use it for spacing. You can use it for a surface finish if you want. So if we look at this, you'll see, typically we see a finish like a number like this, 1.445 inches, 3 decimal points. That's good, right? And it's between here. We know that this arrow is telling us from this line to this line is that. Over here, it's a little different though. They've got a special call out here. So it's 3.566 plus 1 thou minus 2 thou. So when you see something like that, very simple. All they're telling you is in these dimensions, we want you to stay, when you manufacture it, it has to be plus 1 thou minus 2 thou. And again, if I'm powder coating that, I got to know that. If I'm hard anodizing that, I might tell the guy to machine it, hey, you know what? I want you to machine it -2 because I'm going to build it up, right? If you go to the mean and I put 1 thou per surface here and here, I'm going to blow that dimension. So I'm going to want you to machine it a certain way so that I can anodize it, hard coat it into tolerance. All right. And then look at this one over here. This is a diameter. That's the symbol for diameter, circle with the line through it, right? 2.3740 plus 5/10 minus nothing. I might tell this guy, send this to Mario, have him do it. He's upside down, but he's a really good anodizer. So it's something you want to be very careful about. So when you see that, that's all it is. It's just another way to call something out on the print. Usually they look like this, not always. So there are other blueprint details, things that we want to know about, right? There are lines and cutaways and area views that they use them to designate surfaces, show a cross section. They might want to highlight a specific area. They want you to see an angle tolerance or something like that. So this is all other stuff that's on a blueprint. So if we go back to that first part with the 16 that we're definitely not going to rack from, except we might. So they're using a line. You can designate a surface using a line. So if we go back to our little, hey, we need you to machine this line. See the arrow? It's pointing to this line. That line matches up with this surface. So what this instruction is talking about this surface right here, right? These arrows, it's pointing to this dimension here. So that's telling you that 125 is in this hole right here, right? So sometimes they use arrows just to point at something so that to call attention to it and tell you what to do. In this case, here's a print, mask these areas, right? We've got arrows pointing at stuff, indicating holes, things like that. So this is something you do see quite a bit in masking callouts in particular. So they've got arrows. The other thing, and if you've looked at blueprints, you've seen these, right? We have cross sections. And what they do is they take a part, and here it is here, we got this part, and they show with using this dotted line, and in this case, this would be view BB. So on the big blueprint, you would look and find section BB. And what they did was they used this and they cut the part in half. And here's view BB. And you can see they cut it in half and they're showing us half the part, right? Now this would be important. This is a good one because if you were estimating this and you only had this view, you might think that's a nice big hole. What a perfect place to rack from. This is going to be an easy part, right? Or if it said, hey, mask this diameter, you'd say, that's going to be easy to mask. I got a plug that's going to fit right in there. Until you get the part, and then you see the cutaway, and it's a solid bottom. Okay, that isn't a hole. It's a solid bottom. So now Raytheon tricked you, right? You thought you were going to be able to put a plug right through there. No, you cannot. Okay, it's solid. This is what a through hole looks like. Goes all the way through. That hole goes all the way through the part. So the cutaway shows you a really important view and might tip you off onto something. Okay, so then we've got this part here. This is the pictorial view. A lot of parts these days, you see them, wasn't as prevalent in the past, but now with AutoCAD and things like that, you see a lot of these nice 3D views, gives you a lot of information, gives you a nice view of the part, right? So in this case, we have what they call a cutting plane, which is the same thing as a cross section. It just, hey, we're going to cut it in half. We've got the dotted line, which tells us that that's a broken line, which is telling us something. So when they cut that in half, here it is, right? Here's the part cut in half. Now, when I look at this compared to the pictorial view, I say, hey, there's a lot more going on inside these holes than I thought. So that isn't going to be the best place to jam my anodized rack. I want to be really careful with this. I may want to call the customer and say, hey, maybe I'm going to rack through the middle.
Not going.
So that section gives us, again, more information. So when you see these dotted lines and something that looks like this, that's what that is. Is there a question or is that just background? Just background. So now we have a detail drawing, right? And again, this one is highlighting angles. And you can see this angle right here, 45 degrees, okay? And you can see it. And why is that important? Well, we got the cutaway view, right? We can see that, we know that. You can see dotted lines. It's giving us all the information. But if this is a 45-degree angle and I was planning on racking from that surface, is there going to be enough material there for me to really rack from? To grab that if I'm hard anodizing these and I need a good tight contact, and some of that material is gone. Because if you look, it looks kind of solid, right? It looks square until you realize that's a 45 degree. So they're calling that out and they're letting us know that's not quite as thick and beefy as maybe we thought it was, right? So that tells us something. We need to be careful racking there again. And then I'm looking at dimensions and I see 3 decimal points, 3 decimal points. So, okay, pretty average print. Finish is none. I don't see any kind of surface call out 16 or anything like that. So, you know, we can be fairly confident that we can rack someplace else, but maybe end to end right here isn't going to be the best spot. So there are a whole lot of key symbols that are out there, and some of them mean a whole heck of a lot to us. Some of them don't mean so much. You know, when you look at this one, all around profile, I don't think that's going to impact the finisher very much. Total run out, circular run out, least material condition, regardless of feature size. A whole bunch of these that aren't really gonna change our tactics or our approach or our pricing in any way, right? But there are some, and these are a couple that people do miss or get confused a lot. And you know, everybody's got the blueprint that comes in and it says mask the counter bores, right? And then the people in masking bring you the part because they accidentally masked all the counter sinks. A counter bore has kind of a 90-degree bottom, right? And it's usually like a clearance for a screw. You drop the screw in there, and then that way the screw head is below the level of the surface. But that is a counter bore, okay? A counter sink is like when we use a screw that has an angle on it, and it fits right in there, and that's a counter sink. It's designed with that angle in there, that like typically 45 degree, although they can put an angle on that and let you know that it's 33 degrees. So that plug you bought is no longer able to be used. So counter bores and counter sink, very important that we keep those straight. And a lot of times the masking people, that we give them a part and say, I need these right away, hurry up and bring them to me as soon as you're done. You know, we may be putting them in a position to fail unless we've taken the time to make sure they understand the difference between counter bore and counter sink. And there is a depth to these, right? They're not all the same. And that depth is indicated by this little symbol here. And it'll have something over it, like 0.25. If I see that next to this, I know that counter bore is 0.25 inches deep, right? So it gives us that depth, which may be important. If you're doing this chrome and they want chrome plating down in that counter bore, and it turns out that counter bore is 0.75 deep, well, good luck getting hard chrome down in there, right? You know what I mean? That's not going to be easy to cover, you know? So even if you were powder coating it, you know, and you needed to powder coat it, you'd have some Faraday cage issues in there trying to get the powder down in there. So the depth is equally as important as knowing which one is which. Then we have these over here. These are pretty important as well. This little rhombus here, that is a symbol for flatness, right? So here it is right here, flatness. So if this is right here and it's pointing to this surface, that means this surface has to be flat to 50 thousandths, 5 thousandths, right? 5 thousandths. Again, you know, we can raise a burr that's that big, right? By racking something, you know. So if this is a thin part, we may want to be careful racking end to end because maybe we're gonna put a little bend in it, right? So when you see this symbol, that's flatness. That's another one we have to pay attention to. That we can impact that as finishers. Then these two lines here, very simple. What do they mean? Parallel, right? Just means they have to be parallel. These two surfaces have to be parallel to 10 thousandths. Okay, surface A. So these have to be parallel. So again, we want to be careful. We don't want to rack in such a way that we're going to damage this or do something. And, you know, even from estimating, if you're looking at a part and you're quoting it and you don't see any of these things, you know, there's no check marks with numbers in them. You know, there's not a lot of cross sections and arrows and things pointing to critical dimensions, and the tolerances are pretty wide open. well, that's gonna impact your price. You're probably gonna think, yeah, you know, I can do these for this price, right? If you start seeing things like this, flatness, parallelism, you know, 4 decimal point tolerances, okay, that's gonna tell me, you know what? I'm going up a little bit. I need to get a little bit more money. There's some more work that has been put into this finish, right? Into this part. And I need to make sure that I give it the time and the effort that it deserves, because there is stuff here that matters, right? That I can impact and damage. If so, you're gonna want to, you know, increase your handling. Maybe it means we're not going to do 30 on a rack. Maybe it means we're only going to do 20, but we're going to do a good 20, right? Maybe some of these things you say, I better not rack from that surface. So, you know, I can't do them the way I thought I could do them. I got to get a little bit more money. Or you're taking a chance, you know, a lot of detail. The more expensive the part, the more expensive the processing should be, the finishing should be, you know? So those are some key symbols that we're going to look for. And there's a whole lot of lines on blueprints, right? And if we look at this little cube over here, this little box, the visible line, those are the lines you can see. Very simple. A dotted line means it's a hidden line. They're just telling us, hey, this thing's a little rectangle. It's a little block. You know, we want, you know, that's what the other side that you can't see looks like. This is a center line. Sometimes that means that's where they take their dimensions from. So they put a center line in a drawing. So, and they might say, hey, everything comes off of the middle. What's most important about this part is the middle. And then that it's an inch to the left and an inch to the right. That's what's important. Not just that it's 2 inches thick, but that it's centered, you know, because it fits into a groove or something. And it really has to be not just made to a specific tolerance, but that tolerance comes from the middle, you know, which in these little simple parts, it's hard to see. But when you mess one of these up because you didn't realize that it was the center line that was most important, you realize just how important it is, right? So dimension and extension lines, we showed you some of those earlier, right? With the number in the middle, you know, 0.5, oh, it's a half an inch from here to here. That's good. Then you got these other lines here, break lines, long break line, phantom line. What these lines mean when they're broken like that, if you have a part that's 4 feet long, right, and it's a tube, say, and all the machining is done on, you know, 6 inches on the left side and 6 inches on the right side, do we really need to see a 4-foot drawing for the middle, right? That's nothing. You really don't. It's the same from end to end, right? Until the machining starts on each end, right? So they may take a 4-foot part, put a symbol like this in the middle, show you this end, show you that end, and not even show you the middle, right? Because it doesn't change, right? Long break line, same kind of thing. A phantom line means that it's a line that's really not there. It's just there to help you get a picture of it, right? And then we talked about cutting plane lines and viewing plane lines. That's when we cut the part in half, right? We cut the part in half and we look at it to see what it looks like if we take half of it away. If we could slice that cake in half, we want to see what the filling is, right? So then we get to threads, and you say, well, a thread is a thread is a thread, right? Well, kind of no, right? There are 3 different designations for threads. You've got the unified fine thread, you've got the national pipe thread, and you've got a coarse thread, right? Coarse thread's pretty standard, right? You got 1/4-20 nuts and bolts that you use to put your racks together. That's a coarse thread, nothing fancy. You know, there's a certain number of threads per inch, pretty standard. A pipe thread is exactly what it looks like. It's a pipe thread. It's a big thread, right? You know, less threads per inch, and they're deeper and pointier and sharper, and, you know, and then you've got the fine thread, which is exactly what it says. A lot of threads per inch, right? Very, very fine. Now, you want to know what these are, because if you need to mask these, right, or you're plating something that's got a fine thread, there's a lot of little threads in there. You got to get all that water out. How are you going to rinse that?
Yeah. Olive oil in vanilla ice cream, and you never think that's a good combination.
Interesting.
Somebody just offered me ice cream. I heard ice cream. So you've got your fine thread, which is tough to rinse, right? You've got your pipe thread and your coarse thread, which may be tough to mask. If you've got a blind hole that has a coarse thread, right? And you want to try to mask that with a tapered plug. Well, we've all seen when you pull out a tapered plug and water comes out, right? Well, we hope it's water, right? But think about it. You got a thread that's really hard to mask because it's so big and rough and deep, right? And if you just put a plug in there, the chemical you go into a hot solution and everything kind of gases out. Then you go into a cold rinse, and in Boston in March, we got some pretty cold water here, so it'll suck that cold rinse water right into that hole, and it'll repeat that up and down the line. You go into your hard coat tank at 32 degrees, it's going to suck in sulfuric acid. And then you go into your black dye, right, at 100 and something, and all of a sudden out comes the sulfuric acid, right? And you got a big white stain around that masked hole. And you've done a fantastic job anodizing this part, except that we've got some staining around the hole because we had a coarse thread that the tapered plug just didn't fit, right? And if you were racking from them, you might say, hey, coarse thread, I got to be careful. Pipe thread, I got to be less careful, but I still got to be careful because, of course, we're always careful when we rack. And if I see a hole that's a fine thread, I probably don't want to rack from that hole, right? Even putting them on a hook rack for electroless nickel or something, a fine thread or an aluminum part can be pretty soft and easy to damage, right? So even the threads, you might look at it and say, yeah, it's got a bunch of threaded holes. So what? Well, you know what? If they're fine threads and they're plated, they might be hard to rinse. If they're coarse threads or pipe threads, they might be hard to mask. The fine thread is going to be a place you don't want to rack from because you definitely can scratch it and screw it up. So you want to even check the thread dimensions that are there, right? So we're getting towards the end. Here we come. Can we hard anodize this part, right? There's our pictorial view. Nice looking part, pretty simple, right? We got some stuff going on here, and here. We got a little pocket, we got a slot. We can look at it. We know it's a block. We don't have any of those hidden lines, but we don't really need them for this, right? So let's see. So here's our purchase order, right? I'm going to get 100 of these. We got to hard anodize them. We got to rush them ahead of the rush job we're rushing. And our favorite buyer, Ophelia Payne, has sent this order in, right? So the part number is 2tough4u-002. Okay. So now we go to the tolerance block, right? 2tough4u-002. There's a different drawing number, right? But that's okay. Here's our tolerance block, just like the other one we looked at. If we see 4 decimal points, right? So called a masking block. The finish is 125. So that's good, right? We're good there. Oh, 2024. I'm hard coating 2024. I got to be careful, right? Got a lot of copper in that alloy, and copper doesn't anodize, does it? Copper burns, right? So we've learned a couple of things about this part already. So now here's the finish notes, which are sometimes up on the top left, right? So it's black hard coat, 2 thou, +2 minus nothing. Well, that's a little tighter than I like to go. I can do it, but I'm going to charge you for it, right? And I gotta measure it. I gotta work at it a little bit. We're gonna mask all of these areas with this crosshatch. We're gonna mask all the counter sinks. We're gonna mask 12 holes marked A, and we're gonna mask a 1/2 inch diameter around the 12 holes marked A. So that doesn't look so tough. So here's our part, right? So 2tough4u-001. Okay. We got, what's that symbol? That's the counter bore. Are we masking the counter bores? No, we're masking the counter sinks. Here's the counter sinks. Okay, so we know we got 90-degree counter sinks, 12 places, 12 times, right? 12x, quarter 20, UNC, coarse thread, standard thread. So I got to mask it, but I'm just going to use one of those nice self-tapping plugs. Make sure I got one that screws all the way in so that this nice and plugged. We don't have any. Some of those times you use those plugs over and over again. They're not so helpful. They're not so good anymore. All right. We got 3 decimal points, various places. Right here, I have 4 decimal points. So this slot right here is, what did we say? Plus plus or minus 5/10. So I got to put 2 thou hard coat on this, plus 2 minus nothing, and I've got a slot that's 5/10. That's plus or minus 5/10. I got to call my customer. What did you do? What did you machine those at? Right? So there's some things we've seen in here. Right? Just another view. We've got some arrows. Again, there's the counter bore, right? This is showing us the other surfaces that are on there, right? This is the masking when it says mask these areas, right? Mask these areas. Up, we've got a flatness speck there, 30 thousandths, right out in the middle of nowhere this is, but we got to be careful. We've got flatness here, 3/10 and 2/10 on these two surfaces. So there's a few things going on this part that we need to address. So we didn't have any holes marked A. I actually forgot them when I made the drawing. It happens, right? So how many masked areas are there, right? So we've got masked these areas. So we definitely masked here. We're gonna mask here. We're gonna mask here, right? Are we masking here? This is so much better in a conference room because I can throw pencils at people and make sure that they're listening. So if you look at it and people very quite often you'll get a drawing that is made to fool you, not intentionally, but it is. In this case, the guy who drew the drawing said to mask the areas that are crosshatched this way. Okay, these go the other way. It's a small thing, but it's happened to me. Okay, it's definitely happened to me. In this case, this is just calling out a flatness in this area here. Maybe this mounts on something. Maybe something bolts onto that surface and it has to match up really well. So the guy who, the evil bastard that made the drawing fooled us and he put the crosshatch this way. I've seen it happen a million times where people mask everything that's crosshatched, even if it's crosshatched the other way. And I do want to point out, we've got this nice little pocket here. So when we mask this pocket, we're going to mask the bottom because that's all that's crosshatched, right? Okay, that's going to be easy to mask. This area here, it's kind of out in the middle of nowhere, right? That means we have to measure to locate this, right? There's nothing there that tells us where it is to mask it. This we can find. This, we got to measure. And there is something else unique about this drawing that I wanted to show you. I did this as what's called a zero drawing, meaning that everything that comes from the left corner, instead of saying this thing's 12 inches with the arrow and a 12 in the middle, everything is 0, 0, 5, 7, 9, 11, 12, 2, 4, 7, 8, right? It all comes off of this corner and it's a zero drawing. And I did that only because we hadn't really talked about it. We hadn't talked about it at all earlier, but there are some other types of drawings and I wanted to call your attention. So instead of the typical tolerances, the typical callouts that we see, this one's a little different. Okay. And this actually came in handy. I had to replace like 6 tanks on an automatic line one time. And for those of you who have automatic lines, it was a return line. You know, they go up, they go over, they come down, right? And if those tanks aren't in the right place or the rack is swinging or something like that, you get what they call a crash, right? And those crashes are pretty bad. And until you've had to somehow unhook this mess of metal, mangled metal over a 150-degree electro cleaner, you don't really consider how critical that tolerance is. So I had like 6 tanks and I thought about it. I said, the only way I could do this is if I do a zero drawing. So where the last good tank ended, I measured, so, 0 to the other end of the tank was 24 inches. Then the next tank started at 27 and went to, 41. And then on and on and on. And we made this 6-station tank, pulled out the 6 tanks that were there, slid in 1 tank, and every one of them was right on the money, only because I knew that I could do it this way, and it worked, right? So typical stuff. Countersinks and counterbores, did we get that? The dimension of the slot, yep, we saw that. The pocket depth, did we ever really get a depth? In this case, they're showing us that they only show us an end view, but the depth of that is the same as the depth of the slot. And they're kind of telling us that this is our depth. It's a 1/2 inch deep. 0.5 to 4 decimal points deep right there. So that's really it. Sometimes it's better in person because I can tell some more horror stories about various masking dilemmas and disasters that I've had. But I wanted you to kind of ask any questions that you might have right now. I'm going to stop sharing so we can see each other again.
Marco, thanks. That was great.
That was good.
Really
Great.
You sure? Because it was awful quiet. I like it better when I can see people and I can gauge their reaction. Are you getting my jokes or not? And maybe I should work on some new
Yes, we
material.
were.
So we had you on mute so that everyone wouldn't talk at once, but we
I
had
don't mind.
everybody else on mute, not you.
I was gonna say I hope not, but that's okay. The
No.
mouse did all the work anyway. So,
Yeah.
But does anybody have any questions or any war stories they'd like to share?
I'm glad I don't have to read any of those blueprints.
Well,
I started out as a draftsman and as my first real job, and we had to know a lot of the dimension stuff and the tolerances. So it was kind of a refresher for me. But boy, you went way beyond that. That was 45 years ago. So
Wow. Okay.
things have changed. Yeah, things have changed.
Well, and when if you're the estimator or if you're the contract review person or somebody like that, think about it. You might look at 50 prints a day, right?
Wow.
We used to process 100 orders a day, right? 100 came in, 100 went out. And, I would say 50 of them were new, right? 50 of them were jobs we had done before, so they were pretty easy. So, it's very easy to get swept up in missing something on a print, right? And it's easy to, if you're, it's nothing worse than being the estimator and saying, yeah, we can do these for $5. And then they come in and it's, +2 minus nothing, do not rack from here, all of the things that you wish you had seen on the drawing when you estimated it. So.
Why do you unmute it?
Marco,
Why is
Mario
everyone
had to
muted?
log off briefly,
We're
but he
muted.
has a question for you when he
Sure.
logs, okay? Ed, Mario will be logging in sometime soon.
Okay. Okay.
I've got a question.
Okay.
Yeah.
What's the most common error that you see on blueprints from the supplier that you might look at and you say, I wonder if they made a mistake or something like that?
Well, there's kind of a lot of them actually. It's hard to say that there's one particular one, but I think that the story I always tell is that I just have this vision, right? That some engineer somewhere, draws this fantastic part that's gonna, make the missile fly, make the plane land, make the Keurig, make the coffee, whatever it is that's super important, right? And he shows it to everybody in the office and they're like, what, that's fantastic, you solved the problem, that's a great part. And then somebody says, boy, I can't wait to see that plated. And the engineer said, oh, I didn't really think of that. You know what I mean? But, yeah, 2,000 electroless nickel, right? Or 2,000 hard coat and no rack marks. Well, the next job that we hard coat that has no rack marks will be the first job that we hard coat that has no rack marks, right? I ask people, where are we supposed to hold it? And I think the biggest mistake is that just not keeping finishing in mind. Just not understanding, the plater has to hold it somewhere. When we do hard coat 2,000 thick, we don't like, count down 10 seconds and, ta-da, 2,000, we nailed it, right? We don't. We have to have a tolerance, right? And we have to have a tolerance, across the parts, right? We even one rack may not all come out the same. So if they call out these tolerances, and maybe they need them, maybe they don't, they're only costing themselves money, I had a customer come in and they had some parts that when they opened them up in our conference room, sand from a rack came out of them, right? And it was like talcum powder. I never saw such sand like this. It's not the Cape Cod sand that I'm used to, right? And they said, look, we need to redesign this part. We're gonna have 10 of these units here. What it was is it was a device that listened. And if there was like a sniper that shot at a Jeep, right? This thing identified where the sound came from, and like before the echo of the gunshot went away, that sniper was blown up, right? So this thing was super important, and they were like, this is saving lives. We want there to be one in every Hummer in the Middle East, right? And they said, and we need them by Friday. And this was like Wednesday afternoon, right? And I said to them, I said, no. I said, I can't possibly do it. They're all kinds of masking. And they said, well, what can we do? And I said to them, I said, well, why are you masking it this way? And, they were like, well, we can't, we can't have this, we can't have that. I'm like, well, you're making the masking 10 times harder only because, what I want you to tell me right now is, where do you need hard anodized? Where can't you have hard anodized? And really, where don't you care? You know what I mean? Give us some, tell me what doesn't matter, because then you know what? I'm not going to mask it. Or maybe I will mask it because it's easy, So instead of like we had the cover, instead of only like a 1/4 of an inch around the outside was yellow chem film and everything else was hard coat. I said, why can't I just mask the whole inside? They're like, well, that's more money. And I'm like, no, it's not more money. It's way more money to have to measure a 1/4 of an inch all around the outside. So I guess, to circle back, it's just too much of the not keeping the finishing and the plater and the things that we need in mind.
Okay, great, thanks.
Alicia?
So I had someone in LinkedIn who was looking for a metal finisher, and he was a machinist, and he said, are you going to be the next metal finishing company that's going to effing ruin my parts? And the guy was pretty angry when he was sending me the message, and I had to give it to someone else to answer it. But he was frustrated with metal finishers who ruin their machine part. And
Yeah.
so, imagine all the work that they put into making a part. And because maybe the print is there could be errors in the prints, but we're not reading them properly. And now we have to deal with a reject, which means lost profits, fearing
And
out,
lost time.
and fearing out if the part is going to be a fallout, or if they have to remake the part, or are we going to strip the part and, create etching on the surface. So yeah, I've had angry people. Well, actually only one person tell me that. And I thought, hey, this guy's gutsy. I like him.
Well, you know what? I'd rather deal with that guy than the guy that just drops him off and kind of lets you fail, and then he charges you for the parts, I went to a Tooling and Machining Association meeting. It was one of the first ones I ever went to. This was years ago. And I'll never forget, this guy stood up after dinner and he said, when are we going to get these platers to stop ruining our parts, right? And there I was, the only plater in the room, and I really just wanted to kind of slide under the table, right? But I stood up and I said to him, I said, we hire entry-level people, right? We don't have machines that can machine a part, plus or minus 5, 10 thousandths, right? We're dealing with electricity, chemistry, contacts, racking, right? Unskilled labor that we're training and teaching. I don't see a lot of, universities offering metal finishing courses, right? You know what I mean? So when you come from the machining world where everything is exact, right? And that, that machine you buy now, boy, that thing is, that can machine. You can do lights out machining all night long, plus or minus anything you want, right? So they come out of a world that's very exact, and they come into our world that's, 50% art, 50%, science, and 50% luck, right? So, it really, it's hard for the machinist to kind of grasp what we have going on,
It's true. And in plating, you get a heavier buildup on the lower areas of the tanks than the higher areas of the tanks. And yet we want to plate as many parts in one load. So
right.
I mean, there's a lot of science and magic, black magic behind it.
There really is, and I hate to say, that historical knowledge, right? That, I mean, it's embarrassing to me, but I probably didn't tell the customer, but, our best hard coder, Ramon, took Monday off, right? And somebody needs their parts Monday, but I'm like, I really want to wait till Tuesday when Ramon is back, because he's the guy I want running these parts. You don't want me running them. You know what I mean? You don't want my second guy running them. You want to wait for Ramon, and and no machinist will ever say, yeah, perfect. Yeah, I can wait for Ramon, and because it's like, well, why don't you have two guys? How can you only don't you have process sheets? Right? Yeah, what's the process sheet? Soak 1 to 5 minutes, right? And go from there. So it's really not that exact science. And I hate to say it this way, but I tell people, trust nobody, right? Pretend that every machine shop is out to get you, right? I had a guy, he called me up, he said, I have a part that it's worth 10 grand. There's one of them, and I'm sending it down to you. And it's a casting, and I had to wait 6 months to get it, right? So if you mess this up, man, I am 6 months and $10,000 in the hole, right? So I said, well, hey, thanks. He said, there's a lot of mask. And I said, fantastic. I said, take the print, highlight the print for me, and send the part down. So it comes in, nice looking part, right? I look at page 1, there's all kinds of yellow highlighter. Page 2, mask this, yellow highlighter. Page 3 is the same, all the way to page 8, right? I open up page 8, no yellow on the page at all. Nothing's highlighted, right? So we take it out, we run it, nail it, right? Came out beautiful. Couldn't have been happier, right? Off it goes, gets to the customer. A few hours later, Marko line 2, right? It's that guy. I'm like, oh, he must be calling to say thank you, because he's probably as happy as I am with how good it came out, right? He was livid, absolutely livid. You ruined my pot. And I said, I'll be there in 45 minutes. And I got in my car and I drove up there, and I walked in and I said, show me. And we opened it up, page 1, everything was masked right, page 2, masked right, page 3, until we got to page 8, right? Page 8, nothing's highlighted, right? It said, mask this entire surface. Okay, it was the whole bottom of the pot. Mask this entire surface, right? And I said to him, I said, why didn't you highlight? He said, well, it said mask the whole surface. I didn't think I had to. I said, well, you got me. I said, nice job. You got me. You fooled me. I said, so you know what? I said, I'm not paying for it. I said, and we can't fix it. I don't know what you're going to do. I said, but you can't highlight pages 1 through 7, not highlight page 8, and then expect me to pay for something that you really tricked me into doing, right? So you have to watch out for those customers and those things that happen. I mean, it was nice of the guy. Usually when somebody sends you a $10,000 pot, they just don't tell you, and they let you charge $100 lot charge for it, right? I mean, I had people call me up like, you ruined those pots. That was a $10,000 pot, and I'm like, you let me how to anodize a $10,000 pot for $125 without telling me? Really? Like, you couldn't have given me a heads up. Not that I had to charge you $10,000, but it would have been good to know. And if I'm going to assume a risk, I want to know what that risk is. You know what I mean? Don't just throw a $10,000 pot in, And we powder coated a pot for a guy. It was a wave guide. It was made of copper. It was pretty intricate. It was a really nice, brazed assembly. And we painted it. It came out great. Took it to the customer, called me up. Every dimension's ruined. Every dimension is off. I said, oh my God. I said, I'm so sorry. Bring it back, right? So they told me he was there. I came into my office, and he's carrying the pot in a plastic bag, in a market basket shopping bag, right? And I said to him, I said, stop right there. I said, don't put it down. Don't take your coat off. I said, you're going right back to the shop. I said, you have that part with a soft copper assembly that weighs a lot because copper's heavy. I said, and you have it in a plastic shopping bag. And he looked at it, he held it up, and he said, you're right. And he turned around and he left. And they went back and they fixed every dimension, and they made a box with the foam in it so that it set right in, And it was like, that's how can we be held responsible for that? You know what I mean? And again, you look at that blueprint, you'd have never in a million years would any of us have looked at that and said, so this end over here has to be perpendicular to this end over here, as it winds around with this waveguide device, so it's complicated. It's 9.
I think Mario had to leave, so.
That's okay. Do you know what his question was?
I don't.
All right. Well, it's 6:15 your time and 9:15 my time, and I'm a plater, and 9 o'clock, as you know, is the middle of the night. So if I'm happy to continue to talk, and I'm happy to share my presentation with anybody. And please feel free to, if you recorded it, put it up on your website or do anything that you'd like with it. I'm always happy to help out. And, when I graduated from college in 1984, and I was working at a shop. I had already been there for 5 years, and working summers and school breaks and stuff. And I said to the owner of the company, he said, "We want to make you our salesman." I said, "Oh, thanks. That sounds great." I said, "Where do you learn plating? Where do you learn plating?" And he sent me to an AESF meeting, right? The Boston AESF. And we used to meet at MIT. And I remember walking into that room, and I'm thinking, man, these are captains of industry, right? These people, they're running these businesses. These are amazing people. And my point is that associations like yours, these educational associations, you do such a great job, and you educate and bring knowledge and technology to people that there's no other place to get this, and this camaraderie. And, a big shout out to you, Alicia, because, even on the East Coast, people know you. You know what I mean? And people, people talk to me and said, "Hey, you're doing blueprint training for Alicia, huh?" And I said, "Well, how did you know that?" You know what I mean? I said, "Well, I know Alicia. She's on LinkedIn." You know what I mean? So, but you guys are really, people aren't joiners anymore, and we're certainly not meeting at the MIT faculty club, and, right there looking at downtown Boston across the Charles River. And, those days are long gone, but here we are on Zoom, talking across the country, and, and we're still learning and still bonding. And I appreciate you. So thank you all.
Wow.
Thank you.
Great presentation.
Yes, thanks again, Marco. It was great.
Thank you.
Thank you. We do an applause because we've unmuted.
I appreciate that. Thank you very much. I'm happy to help anytime. I owe a lot of
I
my
appreciate-
career to associations like yours.
Yeah, I agree with you.
Thanks again.
Thank
Everyone,
you.
remember our next meeting is going to be really interesting, with Madeline Meyer, talking about nanotechnologies and wastewater. So I hope to see you all there next month. Be safe, and we'll
Okay.
see you again.
Thank you.
All right.
All right.
Bye, guys. Have a great
Bye-bye.
night.
Thank you. Good night.
Good job.